Welcome to Preparing for the ACT 2021-2022, the science section. Here we're looking at passage number 2. If there's a particular question in this passage, you can just jump to that's the chapter section, and look at just that solution for that question. So what we have is we have an experiment where we are adding substances to Diet Cola. And basically the idea is this is sort of like the Mentos experiment, where when you pop a Mentos into a Diet Coke, it creates a lot of foam. And what we're doing is we are measuring this process. Now this paragraph right here is used to kind of describe what's happening in this picture right here. So what they tell us is that we've got this substance, whatever it is, this is the object we're dropping in. And it's wedged right in here, but it's held together with this clamp. And then what happens is we let the clamp go, this object drops down, and then it starts to create some foam. Now, it's not going to create as much foam as a normal Mentos video does, but what happens is that it starts to create foam, which is really just CO2 gas. And so the CO2 goes into here. Now, they tell us that this down here is water. This is H2O. And so what's happening is as the CO2 builds up here, it's going to push the water down, but it's got no place to go. So that's what this second tube, this tube B, is for. What's going to happen here is all the excess water that's being pushed out is going to be collected right there. That's what's happening with this experiment. Now we're doing it multiple times. In experiments 1 through 4, what changed was the types of substances. So we had chalk, sugar cube, fruit candy, and mint candy, the Mentos that we're so familiar with. But the one thing that was kept constant was the temperature. It was kept at a constant 3 degrees Celsius. Whereas in experiment 2, the trial 4 was repeated. So if I go back to trial 4 from that experiment, we were using mint candy the whole time. But what was different now was the temperature. So now it was conducted at different temperatures from 10 up through 60. And here are all our results. So let's take a look at some of the questions. Number 8, if another trial had been performed in experiment 2 and 450 milliliters of liquid had been measured in the cylinder, that is milliliters of water, that's the liquid, the temperature would most likely have been what? So let's go back to experiment 2. Now here are our volumes. 598, which is pretty much 600. 539, that's pretty much 540. 501, let's call it 500. 476, that's about 475. So let's say we had 450. Now, we seem to be noticing a pattern. The amount of liquid seems to be going down as we go. But what's happening with the temperature? The temperature seems to be going up. So it stands to reason then, if we're following this pattern, then the temperature should also be going up here. So whatever the temperature is, it should be bigger than 60 degrees Celsius. And so that's why our answer for number 8, that answer is letter J. Number 9, suppose trial 6 had been repeated, but the bottle of cola had been left open and then left undisturbed. So opened and then left undisturbed for 12 hours before it was attached to the apparatus. Now here's where you have to think a little bit about what you're doing. We're taking Diet Cola, so soda pop, and we're leaving it open for 12 hours. So what's going to happen? Well, it's going to go flat. And so when it goes flat, what happens? Well, it's not as fizzy. And when it's not as fizzy, well, there's not as much gas in the soda. So the question is, would the mass of CO2, that's the gas we're collecting, produced likely be greater than or less than? And so the answer is letter C, less than, because over the 12 hours, the concentration of CO2 in the cola would have decreased. This is exactly what happens when the soda goes flat, is the how much CO2. There is still some when you drink a flat soda, it's just you can barely taste it because it's almost not even there. Number 10, 1 millimole of CO2 has a mass of 0.44 grams. So how many trials resulted in a production of at least 1 millimole of CO2? Now, if I look, they actually didn't measure CO2 in millimoles. They measured in grams. But they just told us right here that 1 millimole has a mass of 0.044 grams. So I can just rewrite this question and say, well, instead of asking how many trials had at least 1 millimole, I can ask how many trials had at least 0.044 grams of CO2. How many times did that happen? So 1, 2, 3, 4. Those 4 did. And then down here, 1, 2, 3, 4. All 8 of them produced at least 0.044 grams of CO2 or more. So that's why the answer is letter J, all of them. Number 11, according to figure 1, which of tube A and B, if either, had at least one end submerged in a liquid before the clamp was removed? Now here they say a liquid. It's not necessarily water. So let's take a look at the picture and see which ones had at least one end submerged. So here we've got this one submerged, but tube A is not being submerged because they would have shown it right there, but we don't see it happening. So that means it was only tube B that was submerged in a liquid. That's why the answer is letter B. Number 12 is the relationship between the volume of the liquid, there's one, in the cylinder at the end of the experiment, and the mass of CO2 produced, a direct relationship or an inverse relationship. And actually, I'm going to highlight those with some colors. So the volume of the liquid, I'll put that in that color, and the mass of CO2 produced. Those are the two quantities we want to compare. Volume and the mass of CO2. So over here, I've got, here's my volume, here and here in table 1 and 2, and then here is the mass produced. And so the question is, when we ask, are they directly or indirectly related? What we're asking is, notice what happens as one goes up or down. So let's see. Here it went down. Here it went down. From here to here it went down again. Here it went down again. But then from 525 to 631 it went up. Same thing up here. Whereas in all these cases it went down. So what seems to be happening is as one goes up, the other goes up. As one goes down, the other goes down. Now let's confirm that down here. Here it went down again. Here's the mass. And in all 3 cases, the mass went down. So it always seems to be going in the same direction. One goes up, the other follows it. So that is what we call a direct variation, because it says as the volume of the liquid increased, the mass of the product, the CO2 produced, increased as well. Now this one probably messed people up because you only saw it increasing one time. And so a lot of people may have thought that it should have been either G or J because it uses the word decrease, and that's what was happening more often. But the idea of direct variation a direct relationship, is that they are doing the same thing. So whether it said increased or decreased, that doesn't matter. What matters is that they are the same. If they were opposite, if one went up and the other went down, that's when it would have been an inverse relationship. Number 13. Consider these steps that were performed. So we have remove the clamp, measure the liquid, insert the solid into the tube, attach the tube to a bottle of Diet Cola. So these steps were performed in what sequence? So the question is, which one has to be done first? Well, clearly this one has to be done last. Because, well, that's what we're trying to measure. And so that's going to be after we drop the object into the cola. So that means letter A is out and letter C is out. So what has to be done first? Do we attach the tube to a bottle of cola, or do we put the solid in the tube first? Well, you have to put the solid into the tube before you attach it to the bottle of cola, because you're not going to shove the solid up and through the tube. It has to already be in the tube. So that's why the answer is letter B. And then 14, assume that room temperature is 25 degrees. How many trials was the Diet Cola tested at lower than room temperature? Now, for some people, the temptation would be to say F. And the reasoning would be this. If we look at table 2, there is only one temperature that's lower than 25 degrees. But here's what you got to do. You have to go back up here and say, wait a minute, these experiments were conducted at a temperature. And what temperature was that? It was at 3 degrees. It's up here. And so that means all 4 of these count towards our total. So all of the first 4 and then one of the last ones. So that's why the answer is letter H. Thanks for watching. We'll see you in the next video.